scream twice without any sound. That should work now. All right, so for the third time, maybe just check out this post if you're interested in this. Soon, new packages will have to use packages by name in Nix packages. Kind of a fairly big change. But anyways, let's jump in. So we have a programming puzzle we want to solve today. I thought Advent of Code might be a nice thing to try. Happens every year around Advent time. Yeah, and so it's a puzzle every day, and we're gonna try solve the first one here. Haven't seen any Nix solutions before, and we might see some like functional programming, how to solve problems in that way, and maybe some lib library functions. Oh, yeah, sorry for the jump scares. Anyway, so the problem is we have our input, it's per line. We want to get the first digit, the last digit, concatenate them together. So we get 12 here, we get 38 here, and then add these numbers all together to produce 142 in this case. And what is the sum of this? We have our puzzle input here, so it's quite a bit longer. Depending on how slow Nix is, we might need some optimizations later. But anyways, let's jump in at last. So I'm gonna go into a new directory here, just open a default on Nix. I'm gonna use the kind of reg pattern here just to get to be able to easily evaluate these attributes. Okay, so we're just gonna use lib, and yeah, so let's just get our test input here. And maybe, I mean, how should we read the input? I guess we need a file for that. Nix Hour 59. We're gonna add test input here. Just gonna paste this. All right, and apparently my notifications aren't stopped for some reason. Okay, so test input now. Well, I want to be able to evaluate this easily. So let's do here's a test input. Now we can use built-in stat read file, but if we try this, so Nix, I'm going to use NE, that's an alias NE for Nix instantiate eval, and we want to evaluate the test input. And I guess this works. Sometimes you don't want this final new line here. Well, editors add this by default, so I can't really remove the new line at the end here. If you don't want this, you can use lib.fileContents. It's kind of a wrapper that just removes the final new line, and now it's not there anymore. Okay, now let's just do very kind of roughly here. I'm gonna split it into lines. Now, I guess again, same pattern. We can use built-in stat split. Split takes the characters you want to split by, so in this case, a new line, and then we run this over the test input. Now, let's see what this is. Lines. Yeah, and this, well, it's kind of terrible. We looked at this before, but so the best solution here is to use lib.split string instead. That kind of does the thing you might expect from this. So it actually splits it like this. And I guess if we do this, well, actually, yeah, I guess this is a good reason why we want file contents here, because if we use built-in stat read here, read file, it would give us a final empty one, since right there's technically an empty string after the final new line. So we have the lines. Now let's do a function to kind of turn the line, or maybe, how should we do this? I mean, each line can have arbitrary many digits. We only want to get the first and the last. Maybe let's just split the string into individual characters and filter for numbers, something like that. So let's say, I'm just going to do result here, and we're going to map each line. So we take the line, one for each, and then for the line we can use, actually, let's use Let's use Noodle today. And I think, yeah, this got a new interface, I believe. So actually, yeah, let's try it here. So we want, what kind of function do we need? We have a string and we want kind of a list of characters, but there's no characters in Nix. It's also just strings. So that should be string to list. Let's try this. Oh, can we? We can. Here, this looks pretty good. String to characters. And we can see here what it does. Apparently it doesn't handle Unicode code very well. Just splits it into, I guess that's, what is that? Forgot the name. Anyways, string handling is complicated. Let's use string to characters. In our case, we fortunately only deal with ASCII characters. So maybe let's just start with this and evaluate this. What is this? Okay, now we have the individual characters. Now we don't care about all the letters, so we can just filter for the numbers. How would we do that? We can use lib.filter. And by the way, that's the same as built-ins.filter. But generally you'd want to prefer using lib if you have it available, since that, well, in case there's some problems with built-in functions, lib can just be deprecated and can be replaced with better functions, or it can receive kind of behavioral changes which couldn't be done in the built-ins. But so we want to filter this one, each of these, and so we have kind of a character here. How do we check whether it's a number or a letter? There's no like way to directly transform this into like the integer representing the ASCII character. We could do something like a hard-coded list, like we could say numbers, then we could say lib.genList. So genList takes, I think, a number as the, maybe let's check here, genList, lib.genList, it takes the number as a second argument. So that generates a list, and we can see it here. It takes a number and then it runs the function for each number and returns the result in the list elements. Now we can say, let's say I, and actually we want a toString I. And how many do we want? We want 10, so that should go from 0 to 4, or from 0 to 9. And so this should be, yeah, let's evaluate it. Numbers. Oh, need something here. Just fill in char for now. So yeah, we could do it like this. And well, I mean, we could try. So if we did it like this, yeah, so in the comments we have, there's a lib function for parsing ints. That would be another way. Maybe let's do that afterwards. But if we did it like this, it would not be that great, because we would have to check whether the char is in the numbers list. And this elem here is, I'm not sure if it's here, and maybe let's switch it up as well. So I'm not sure if Noogle, well, ideally it would be upstreamed. But we also have, it's not as great, let's practice manual. In the manual, we have all the functions as well. It's a bit, it's much harder to find stuff here, though. So like, right, we have all the sub-libraries here. It's more of a reference style here, not very interactive. And so elem might actually not be documented here, and that's another lib.elem. Yeah, it doesn't seem to be here, a lib.lists.elem. Yeah, it's not here. Well, that's kind of a problem because, well, it comes from the fact that lib just kind of re-exports the built-in symbols. Noogle has the benefit that it actually lib.elem. Oh, why does it just forward the ones from the built-ins? Maybe. Yeah, it seems to be. It doesn't. There's no mention of runtime performance though, but you can kind of imagine it. It needs to search a single element inside a list, and that's taking a linear time. and we are already in like a doubly looped code path here. So we might want to try avoiding that. But for now, I mean, let's run with it. Let's see result. All right, that's looking pretty good. But indeed, oh yeah, we now have strings, well, numbers inside strings. That doesn't really work. But there's a toInt function which we can use to parse integers into a number. It's how it works underneath. There's no built-in functionality for this really, or I mean, it's a hack. Can we go to the source here? I think, oh yeah, this points to a fork, but it should be up to date, I guess. Yeah, so if you can see here, it does some matching with the regex. Some checks against 0 prefixes, because those would not be handled by from JSON, which is actually used to do the conversion. So it is very hacky, but it's the only way to do it right now. So we filter by the ones that are numbers, and then we can do a lib.map. By the way, map is one of the few functions that are available without even built-ins. So you can use built-ins.map. You can not use any prefix, or you can use lib.map. Oh, we used it here as well. Let's maybe stay consistent and use lib all the time. So lib, now char. Okay, so we kind of want to map over this again. I should format this to be a bit prettier. But yeah, let's use toInt here, char. And then this should be all in here. I'm actually going to run, so there's an RFC 166, which I'm a co-author of, and it's about Nix formatting, and there's a proof of concept kind of implementation here, and you can try it out yourself as well. Here's the info for that. But yeah, I have it set up locally, and I don't think it's the latest version, so take that into account. But I should be able to format it. Yeah, this, I mean, it is kind of messy code. And so maybe let's refactor this a bit into, I think this here is the messiest part. Let's use a lib.pipe here. Pipe takes, kind of pipes a value through a list of functions. Oh yeah, I need to read some comments. So lib.pipe, let's do that in a bit. So we start with line, then we get a list of functions. And now the first one is lib.string to characters. I turn the characters into a list of characters. Then we filter these like this. We need some parentheses here. Finally, a map like this. Okay. And is this, yeah, okay. Let's we need to evaluate some more. All right, result. Oh, yeah, this is actually embarrassing. Lib.map is not in lib. All right, that's not great. That should be fixed, really. Anyways, so we continue. We now have numbers. Let me briefly read the chat here. Maybe picking first and last digit with one regex would be more performant. Oh yeah, that could be done as well. Oh, and yeah, we have the pipe suggestion in the chat as well. Yeah, that's a good idea. There's also an RFC about a pipe operator. It's currently not being worked on, but if you're interested in getting some like built-in Nix support for something like pipe, this is the RFC you might be interested in. Okay, let's maybe we can try out the regex solution later by kind of parsing first and last digits. But for now, I'm going to continue here. So now what do we have? We have a list of chars, and actually let me do this. Let me refactor this into a function, kind of process line. So we take a line and then we put, yeah, actually that's this. And then we put it through the pipe here. process line. Okay. Oh, all right. So result. Okay. So now next things we need to do. So maybe like something I sometimes do is to annotate the code here with kind of the what the state of the data is at that point. And so in here we get the line. So this might be, I mean, let's copy it from our test input. Kind of like this. And actually let's add like a third number in here. And like A, B at the end. Actually, we might as well pick this one. Okay, this, and then in here we split into characters. I kind of don't want to type this out though. Well, could we do? Well, let's do it just like this. 1B ... All right, that in a list. Then we filter the ones by numbers. So we have 1, we have 2, we have 3, we have 4. Oh, and 5. All right, now we map these to actually integers, so we can remove all of these. Okay, next things we need to do, we need to get the first and the last elements. We can do this with, so we take the numbers here. Well, let's call it, we have numbers already up here. Let's call this digits, might be a better name. Digits. All right, now the numbers, we take the head. Head, I don't think that should be available in the global scope. Head numbers, and is there a last? I believe there is a last. Yes, lib.lists.last. So, well, what do we want to output? We could output still a list, but we only have 2 elements. We could add them right away, actually. Yeah, lib.last numbers like this. And now we get 6 in here. And let's test this. Result, indeed, we get 6 for the input we tested here. Yeah, actually, this would be neat if we could like show some more debugging information here. I do have some idea how we could do that, but let's try to finish it for now. So this specific problem. Now the last thing we just need to do is to add all of these. Well, actually, oh no, I did it wrong. We don't need to add them, we need to concatenate them. So that would be 10 times the first one and then add the second one. Yes, so that should be 15 then. Yep, that looks good. All right, now we just add all of these. How can we do that? We can use a lib.fold L prime. There's also fold L. It doesn't really matter in this case, but generally fold L prime should be preferred. It evaluates things more strictly, and that makes sense in this case since we have just a number. There's no need to have any laziness here. Okay, so fold L prime. Let's maybe look to Google as well. Fold L prime. So this is actually a case where lib.foldL prime and built-ins.foldL prime are slightly different. And you can read about this here. Yeah. Anyway, so we take, how does it work? We have an accumulator. We have the number, and then we return something. And let me just return the accumulator for now. Yeah, and so we need, oh, actually, no, this isn't right. We need to do this down here. So, right, we processed all of the lines, and now we need to do this. Let me use another pipe here, lib.pipe. This should be lines. For each of the lines, we do a process line. All right. And then we do one of these, fold L prime, and oh yeah, we need an initial element here. So the last argument here we get from the pipe, but this one we still need to provide. And that would be, we start with 0, right? So the accumulator, that's the kind of sum. And we add the number to the sum and return that as a new sum and map over that. Yeah, we have a, oh, map process line. Oh yes, that's a good point. Map process line. Okay, and we get a result. Let's confirm, yep, that is indeed the value we should get for the test input. And now, well, we need to try it with the full input. Let's put this in here. And result at, let's now do, I guess we can, let's do this, inputs. We have the test one, that's, well, input files, let's do it like this. And so we have a test input, and we have the input, the full one, full. Okay, and now, well, we need to do some thing here. We need to kind of generalize this a bit. Let's go down here with this and say kind of results. Well, results equals, we can do a map attrs here. Name file, input files. Okay, and then we do a something like this in here. So we contents, we say the lines, that's split over the contents, and then we do well, result. We need to also kind of put this in here like this, I believe. Okay, process line, digits, input files, and let's actually move this down here. It's a bit cleaner. All right, results, let's see if it works. Results dot test, very nice, and full one. Oh, yep, that's a problem. Need to read the actual file here. And we get this. Let's see, answer. That's the right answer. Very nice, we get a gold star. Now there's also part 2, but maybe let's briefly go in here and do some changes. So one of the things I wanted to try was to write kind of trace in between the pipe. What if we do like a tracing pipe function, which works just like pipe but traces all of the values in between? Yeah, that sounds kind of interesting too. So trace pipe, we need to know what pipe really does. It takes the input and the funds as a second argument, and I guess we could use lib.pipe underneath, so we could like kind of splice funds and like do like funds 0 trace funds 1 kind of thing, but that feels a bit too manual. Or a bit too like, there's no need to use the list here, because we can also just use fold L prime underneath. How we would do that is, well, again, we have an accumulator. In this case, we have the, or I guess this is the value in this case. We have the function, and we get initially, we get the input value, and then we map over all the funds. And this is kind of how the pipe itself is implemented. Oh, someone mentioned lib.intersperse. I didn't know about that. Intersperse, neat. Oh, that appears to be, oh, is it only for lists or for strings? It says strings in here, but I wouldn't be surprised. Well, actually, no, it seems to be Only for string. No. Concat map, there's nothing specific for strings in here. So actually this could be moved to, yeah, this should be a list function. Why is this in lib.strings? Okay, that's something to fix. Pierre, appreciate it. So we could use that. Let's use default here for now. Oh yeah, there was a lib intersperse. So in lib, most of the functions are also re-exposed as lib.intersperse. But yeah, these are just links to the underlying function. Well, yeah, it's the same one. It's the lib.strings one. Yeah, okay, so tracing pipe, let's say, so for each kind of iteration, so for each function, I guess we want to print the value. Well, we have the initial value. I guess we also want to print that. Then we apply the function and then we want to trace it again. And so I think we want to here do like evaluate, then trace. So we do, well, we need to use built-in trace here, but well, actually we don't. Let's use a let in new value equals fun on the value. Okay, then we do a built-in trace of the new value. I'm going to use lib.generators.toString in this case. Let's kind of pretty. Actually, we should not use this snake casing. I think. Yeah, let's use a camel case here. Pretty. That's lib.generators.toString. Now that takes an argument. We can pass multi-line true or false here. Do we want multi-lines one? Probably not. So let's not do that. And then we want to print the new value. All right. And actually, let's do this here. Pretty print. I'm gonna put this function right here. Okay, pretty print the new value. Now we're gonna trace the pretty value and then return the new value. Okay, and I also want to print the input. So, and this is actually a great opportunity to show the difference between lib.full L prime and built-in.full L prime. We'll get to that in a bit. And actually, we can use, let's use trace value here instead. So we're gonna turn this into built-in.trace. We're gonna trace, well, we're gonna take a value, trace the pretty printed value, and then I guess return it, yeah. That's a kind of more reusable function. Trace value, and yeah, right, we don't need this here then. Trace value. And then new value, we can do this right away. Yeah, that's easy. Okay, find value, trace value, and then we also want to trace the value here. Okay, let's try this out. So process line tracing pipe. And evaluate this. Let's just use the test input. And we get toString missing. That's pretty. What is it? Let me look it up. Generators.pretty or to. Oh, it's called toPretty. There it is. We have a question. What exactly are these functions? There's like, I can't quite read that. Top leveled like this, or I guess why are they top leveled like this? That's just because it's kind of more convenient this way. So if you have lib available, you can use, well, you don't need to type the lib.strings part. Though sometimes it's not great, and actually I'm not sure if the bug was fixed, but Noogle had a bug here. But there's actually 3 different versions of has prefix. And traditionally, only one of them existed, the string version. And so that's what has been exposed in the top level. But now there's also a list-based version and a path-based version. And so these, these now can't use the kind of top level thing, and it might be better to deprecate the lib.hasPrefix one. Okay, now lib.pretty, and that looks pretty good to me actually. So we get this, we get the split, we get the numbers, and yeah, we actually see, well, I was wondering about this, what happens if there's only one number, but apparently this is answered. And also it looks like there's no lines without numbers in the input, otherwise it would have thrown an error, right? Since lib.head and lib.last, they need at least one element in the list. Okay, and we also have another pipe somewhere. Where is it? Up here? Tracing pipe. Let's also try it out here. And yeah, now actually we get into the problem that it's kind of hard to distinguish what really happens. So let's maybe add some like better tracing. I'm gonna do maybe this. So I'm gonna say the string is this. Okay, and then we're not gonna print the string directly. Actually, yeah, what if we print the number that we're currently processing? That might be interesting. So, well, we kind of want something like, yeah, or maybe let's call this context. Context, and so context, we just prepend the context to the string to print. Okay, now trace value. So this one is the initial. Okay, and in here, well, we kind of want the number in here, but we don't have the number. So what we kind of need to do is to have use lib.imap0 in this case. So imap0 just kind of is a map function, but you also get the index of the element. And so if we put this down here, and I'm going to format this a bit differently like this. Imap, so we get the integer, we get the function, and now, yeah, what do we do? I guess we can put this into an attribute set here. That's not the most efficient. Lists would actually be more efficient here. Could also do that, but that's a bit of a pain to access. So let's do this. I guess we can just inherit these and make this smaller. Okay, now we don't just have the fun here, we also have the I. All right, and now the context here should be toString I. All right, so let's give this a try. And that seems to work. But we're still kind of missing some context here. Right, we have two trace pipes kind of interleaved. Let's try to make this a bit better. And we kind of want to say the tracing pipe should also have a context. Maybe let's do it here. Tracing pipe, add a context here. And so in this case, process line, we're just gonna add like no context, I suppose. Yeah. And then tracing pipe here. Oh, actually, no, here, this should be no context. In the process line, we want the kind of line specific context. And I guess for this, we also need like an integer. And so we kind of want to say, how about we like indent this by 2 spaces and then use like toString I, and maybe let's do like a line number colon, like this. Okay, and then we also need to use this context in here somewhere. Let's not try to, well, this one overrides this context here. Well, not overrides, it shadows it. And so let's say context, parent context. All right, and so we add the parent context onto the message. Okay, and should we do this? Let's do it like this. Or I guess this seems fine to me. All right, so I guess we want this then, and let's see. I cannot add a function to an integer. Did I miss something here? Tracing pipe. First one is the parent context. Tracing pipe. Did we pass it in all the uses? We did. What happened here? What did I mess up? Oh, not sure right now. Maybe let's read the error a bit more closely. And so we fold L here. That's line 19. So cannot add a function to an integer. So supposedly this is an integer, this is a function. Why is that a function? Oh, process line, right. Process line now takes an I. Yeah, we missed that. So I guess we're gonna insert a, oh yeah, we can actually just use IMAP 0 in here. Well, not quite. We're gonna have to change the, actually no, that works. That just works, yeah. IMAP 0 takes, yeah, that's exactly the signature we need. And if we try it out, this is not quite what I was hoping for, but overall it seems to work. So process line, we want kind of initial, we want, so this looks good. Line 0, so this is all for line 0. Line 0, line 1. I guess. Maybe we should like indent this one. Yeah, this should probably clean things a bit up, and then let's see how this looks. Not too great. Maybe let's remove this one. No, the other one. Here's this one. String printing is always kind of fun. Well, it kind of works now. I don't want to spend too much more time on this. Line 0. And, oh yeah, this is then the one from the outer one. Let's keep it like this. Well, we have the overview. Okay, now we made it a whole bunch more complicated though. But anyways, we have like only 5 minutes more. Maybe we could jump into the second part here, but oh, here it is. Let's briefly check it out. Could we do that in 5 minutes? It looks like some of the digits are actually spelled out with letters. Oh no. They also count as valid digits, only 1 to 9, no 0. Oh yeah, that's going to be a bit more painful. Actually, it might not be that bad. Oh yeah, actually, we could do something kind of neat here. Let's do that. So we're going to do something like this. Number replacements. Actually, it might be fairly easy. So what we can do here is, well, 1 equals 1, 2, 3. Oh god, do I need to type them all out? I can copy this. Well, I can copy that and then maybe like this. Okay, and then 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, It's a very manual process here. I guess this could also be done programmatically. Anyways, and then we do something like, so we go in, I guess in here. And so for each line, before we process it, we do a built-in start replace strings. This is pretty much what we need. And so the first one is the strings we want to replace. So this will be lib.attr names of the number replacements. And the ones we replace them with is attr values of the number replacements. And I guess we have like numbers in this case. So it's going to be bit9, like a toString here. Okay, and then let's just give this a try. 29 list while a string was expected. Map to string attr values number replacements. Where does it say that? Fold L. Wait, so let me reason about this. Replace strings. Let's look this up. Replace strings. Yeah, that's how it's supposed to work. We have the attr names. That does sound correct. We have the attr. Oh, they're actually, is that a problem? They're not like alphabetically ordered, but they will be alphabetically ordered, so that shouldn't be a problem. Lib.attr values, we map these to string. And I guess actually we have like a tracing pipe here. Initial to 19. I guess our tracing pipe here didn't help very much. But I guess it happens in here. Oh, we have overlaps. That's great. Oh yeah, that's kind of terrible. Okay, yeah, I get the meme now. Yep. I wonder, is this the problem here? I guess it might be the problem here. There, see values list while string. This is different error though. Why did that happen? Okay, so it points to this. A string was expected. This is a terrible error. Lines. This should be a line. Yeah, I'm not sure if we can actually do this in the remaining. Well, I need to like leave right now, so maybe not. But it was worth a try. Partially applied function, right. The line is, we don't have the line traced here. Anyways, well, we got the first challenge done. And this could be a first attempt at the solution. I'm not sure how replace strings works when there's multiple being replaced at the same time. Guess that's, if you want to continue, I'm going to commit this later today. Oh, I forgot to map again. Oh, I see. Map. Can we do that? Oh, we can. Oh, and that, wait, does that work? 281, wait, that actually works. Well then, full 53355, answer, submit, not the right answer. Well, we tried. All right, anyways, thanks for watching, and yeah, see you next time.